Hello and welcome to part 8 of the RIMAR video training series. This installment is going to be on water quality modeling, volume versus filtration. In the last video, we went through why you might want to consider using our RIMAR water quality filter and how it does a volume-based design. A filter-based design instead of volume-based design. And this is going to go through a quick example to kind of show you the benefits of doing that. So we've already been through several of these. So we went through basic skimmer design. We went through SETCAD. We did a case study for permanent use. We talked about the HydroFlow hydrographs. Like I said, in the last one, we did a volume-based versus filtration-based water quality. Just talked about the benefits of that. And so this one is going to be talking about water quality modeling. Again, the volume-based versus filtration-based design guide. So we're going to look at a sample site. So the typical volume based is first flush, or whatever that first flush volume is. Typically, it's 1 inch, 1.2 inches in Georgia, up to 1.5 inches in Indiana. It may vary from state to state, but it's in that 1 to 1.5 inch range typically, and it's generally released over 24 to 48 hours. Versus a filtration based design that's based on the flow rate of the filter. So we're going to work on a sample site here as an example. So got a 5-acre site. We're going to assume that the pre-development condition is fully wooded, curve number of 55, and post-development condition is going to be fully commercial, so we're going to pave most of it to a curve number 92. So the first thing we're going to do is we're going to run through our hydrology model and determine our pre-development flow rates. So based upon a 5-acre wooded site with a time of concentration 48 minutes as an example, we determined a pre-development flow rates would be 0.72 CFS for a 2-year storm, 3 for a 10-year, 5.42 for a 25, and 10.72 for the 100-year. This is our pre-development flow rates. So the next thing we're going to do is we're going to determine our water quality volume and our post-development flow rate. So based upon a 5-acre commercial site, we just assumed a time of concentration of 10 minutes, and we're going to calculate the water quality storm event and post-development flow rates. So for this example, we're going to assume our water quality storm event generates 1 inch of runoff volume for the developed site. So over 5 acres, that's 18,150 cubic feet. And so using trial and error, we came up with a storm of 1.73 inches. That would be a 24-hour storm event to generate that approximate water quality volume. Now, if we run that through our model, that water quality storm peak flow rate is going to be 7.23 CFS. 2 years can be 19.72, 10 years 30.4, 25 is 38.53, and 100 is 53.35. So under traditional designs, what we usually do is we determine that first flush orifice size to drain that volume over whatever time period. So in this case, we're saying we've got a 5 acres contributing area. We're using a dry pond, and that first flush volume is based on 1 inch over the total area for the dry pond, 18,150 cubic feet. Now we're going to drain that over 24 hours. So the average flow rate required for that is 0.21 cubic feet per second. We're going to factor in our elevation and such in there, an average head, and run through that spreadsheet, and we come out with a 0.21 feet or a 2.6 inch orifice would drain that volume in approximately 24 hours. So now we're going to assume contractor may have a hard time putting in a 2.6 inch orifice. So we're going to put in a 3 inch low flow orifice here in our design. Again, that water quality volume is 18,150 cubic feet. So that'd come up to about 3 feet in this hypothetical pond. So at the 3-foot elevation, we put in a 3 inch orifice to control the 2-year storm, and an 8 inch orifice about 2 feet above that for the 10-year storm. And then our riser is at 117.5. So bottom of the pond here is at 110. So we got a 7.5 foot riser in there. So when we look at that, our peak flow rate for our water quality event is going to be 0.25 CFS. The peak flow rate for the 2-year storm is 0.81. If you recall, the 2-year storm pre was 0.72. So we've got just under a 0.1 CFS increase there. In our 2 and a 25-year storm events. The peak elevation is only 12.5 feet, and it only uses 10,672 cubic feet of volume. So remember, in our example, we had a 18,150 cubic feet first flush volume that we assume magically appears in the pond instantaneously, which obviously does not happen. So in the real world, when you run that storm event with the hydrograph, you're only using about just under 11,000 cubic feet of volume. So in reality, you've got a half a foot or 7,000 cubic feet of volume that essentially you can't work with for your pond. And so if we look at our um, overall analysis here, our 2-year storm, the pre was 0.72, coming out of the pond is 0.8. 10-year, we had a pre of 3, coming out of the pond is 2.75. And then this is the storage required for each storm event. I'm not going to worry so much about the 25 or 100-year storms for this example because we're really focused on the water quality event and the 2-year event for this. So the alternate here is to do the skimmer with filter design. So as we discussed last time, the Rymar water quality filter details, they size the filter so that it works with the max flow rate of the skimmer. So we're going to just kind of ignore the filter as far as the modeling goes. We're going to focus on the skimmer. We had a pre-development 2-year rate again of 0.72, and if we look at our chart here for a 24-hour peak flow rate, and this would be at roughly a 4-foot depth for these rates, our 6-inch skimmer with a 6-inch orifice flows at about 0.78, so just slightly over that 0.72. If we look at our options here, that's probably the one that's closest. So we're going to model it to start with and see how that works. So again, the filter itself is designed to keep up with the max flow of the skimmer. So for a 6-inch skimmer, this inner skirt is going to be 16 feet this direction, 8 feet this direction. Excuse me, that's going to be the inner skirt. And then the outer skirt for our 6-inch is going to be 20 feet in the outer L1 and 10 feet for L2. So with it being 10 feet, um, it's not going to get too close to our riser here. Again, 10 feet is the total length, so we really only have 5 feet from the skimmer to the riser side of the skimmer. And so as the skimmer comes up in the water, it's not going to get close enough for the filter to actually touch or get hit by the outlet structure. And again, we went through last time the inner skirt and outer skirt, but just quick review. Our inner skirt is the Adsorbit. It's 2 panels with slits in it. It's about 36 inches deep. And then the outer skirt is a polypropylene panel, a Mir 5402 woven geotextile. It's also about 36 inches deep. Then we also have our pond details again. So this could be in a wet pond or dry pond. And we have all the information you'd put in here for that. So now let's look at what happens when we run the pond design. So in this case, we're going to use the 6-inch skimmer for water quality, and we're going to use it to control our 2-year storm event. So we're going to get a higher flow rate for our water quality storm. So now we're releasing that storm at 0.7 CFS. Remember, before we were only releasing it at 0.25. And the skimmer's controlling the 2-year storm at 0.78 CFS, which again, our 2-year storm pre was 0.72, so we're a little closer to the pre. I want to point out here, we're only using 7,600 cubic feet of volume for the water quality storm, comparing that to the 18,150 cubic feet based on first flush. The other key thing to note here is our skimmer is controlling our 2-year storm. So that volume, we're actually treating up to 27,268 cubic feet of volume in the pond up to an elevation of 14.68. So almost a 5-foot depth. So we're setting at our next orifice here at the 114.8 would be our 8-inch orifice. So what we're doing is any flow in the pond below that 8-inch orifice, almost 5 feet of depth in the pond, is now being discharged through the filter and the skimmer. So we're treating a lot more of the annual rainfall by doing that. And as we talked about last time, even the small low flow events are having to go through the filter before they get discharged. And so if we compare the two ways to do this, the traditional design, storage required, or I guess this would be the skimmer storage required, and then the traditional design storage, you see that these numbers are significantly less for the skimmer design. And if we do a percentage of that, you can see it for the water quality storm, we're looking at almost 30% less storage required with a filter-based design versus a volume-based design. And if you go to the 2-year and out to the 10, 25, and 100 year, you're looking at 14 to 12% smaller storm or smaller pond volume in order to do that. So in summary, real quickly, going with a filter-based design versus a volume-based design, you are smaller ponds. Probably when you average that out, you're going to be in the 15 to 20% less volume required in your pond to meet your requirements. You're going to treat more rainfall. So if you design that skimmer to control your 2-year storm event, you're going to be treating up to that 2-year storm event versus a traditional design only treats that first flush volume. And our testing has shown that we get 90% TSS removal. So you're going to be treating that to a higher rate and fully meeting your requirements for water quality at that 90% TSS. So hopefully this makes sense. Kind of quick example of that. But if you have any questions, please reach out to us at info@rymarwaterworks.com. I want to thank you for watching this water quality modeling volume-based versus filtration-based example. If you'd like to receive continuing education credit, please email us at this email address and do that. And you can go to marleyfloat.com or rymarwaterworks.com and look for the spec page under the Marley Float. There we've got our engineers pack, which has all of this information that you'll need. It has a design guide. It has our testing data, has the details, has information on the adsorbent fabric if you're interested in that. So everything you'll need in order to incorporate it into your plan. And we appreciate you watching these tutorials for that. But if you have any further questions, please reach out to us. Again, my name's Jamie McCutcheon. I am the inventor of the Marley Float and owner of Rymar, and we appreciate you considering us for your next project. Thank you.